Hey everyone, my name is Anurag Chauhan. I am Director of Marketing for our wireless product. And today we are demonstrating the LE audio capability of our latest generation of chips. So what we have here basically is 3 product families which are capable of doing LE audio. So one of them is 55310. This is our latest generation Bluetooth Classic plus LE chip. And then we have 2 products from the Wi-Fi family, 5551X and 5557X. These are our latest Wi-Fi 6 product. So what Auracast does is basically it's an LE audio capability which allows for one-to-many broadcasts. So today in the setup what we have is one source through a gateway and then 5 speakers connected to that. Now my friend Hardik will explain how the demo is set up and how the technology works.
Okay, so today we have A2DP to Auracast transcoding demo. So as we know, A2DP is 10-year-old and it has its own limitation. So back then when I joined like 10 years ago, at that time A2DP Bluetooth was the only option, but it has its limitation. Let's say like when we want to stream left and right thing, correct? Then we cannot like achieve that one. So all the like companies come up with their proprietary solution, but it's not spec aligned. So it has its own limitation with power consumption as well. So that's why we come up with LE audio technology, which enables like multiple different use cases, which was not possible with our classic A2DP audio. Okay, so right now we are using Auracast. So Auracast is nothing but LE audio broadcast. So here we have 55513 kit, where we will just connect our phone and stream A2DP music, which will be like broadcasted to multiple devices. Okay, so here we are running in embedded mode. So just to explain, there are like different mode in we can use our chip. One is embedded mode and other one is hosted mode. So in embedded mode, Bluetooth core, application, stack, everything's run in a single like chip itself. And in a hosted mode, Bluetooth controller and stack can run on a separate core. Okay, now let's start with the demo first. So I have connected my phone with 55513. So that is our normal A2DP connection. And here we have like different like devices which will receive the Auracast. So let me just like first start the demo. So I will just start the music. And as you can see, each device are like listening to the same Auracast music, and we should able to stream the music. I will let you enjoy the music for some time first.
Rough on the surface, but you cut through like a knife. And if it wasn't open,
Okay, now let me pause the music and explain what are we doing here. Okay, so here we have 55513 kit, which we are running in embedded mode. It will exchange the like data there, correct? So here on the receiver side, we have multiple devices. So first one we have is our custom RPI kit with our 5557X chip. So here also we can use 55513 as well as 555310 as well. Okay, so this is running in a Linux hosted mode, correct? And here we have our PSOC Edge kit with 55513. Here also we can use 5557X or 555310. So we have like option, we can use any chip here as well. So this is PSOC MCU. So here this is running right now as in a RTOS. So our Bluetooth stack and applications are running in RTOS, and our like 55513 runs in a controller mode only. And here lastly we have 555310 kit, which is running in embedded mode. And here let's say if we want to use as a transcoding 555310, then also we can use this 555310, and which also can like receive A2DP data, and it can do LE audio transcoding as well. Okay, and here we have off-the-shelf 2 market device which like support Auracast. So we can just like put in a receiving mode, and it can just receive the Auracast stream. Okay, now let's go in like little bit more technical details. So as like I explained, so here we are doing A2DP to LE audio Auracast, okay, and here everything is run in embedded mode. So let's see how things are done. Okay, so when we stream music from the phone, so it is a classic ACL BREDR link, so where it will receive the data, and here it is using A2DP. So most of the A2DP use SBC codec, and on LE audio side it use LC3 codec. And in LE audio right now we are using 48K sample rate. So whenever we receive the data, it like convert the first, like it receive the data, then it like does the decoding of received SBC data, and it just convert to the PCM samples, but that are at 44.1K sample rate. So we have inbuilt ASRC algorithm running, so which will convert 44.1K sample rate to 48K sample rate. Post that, we do LC3 encoding, and then we send the stream to Auracast. So you can imagine what like this embedded chip can do. So it receives A2DP data, then it does like SBC decoding, then ASRC conversion from 44.1 to 48, then it does LC3 encoding, and after that it just does Auracast or ISOC stream. So everything does like in a single CM33 chip itself. Now coming back to A2DP versus LE audio. So as we know, A2DP is little bursty traffic and LE audio is predetermined traffic. So based on the ISOC interval, that can be 7.5 millisecond or it can be 10 millisecond. So our engineering team has excelled, and we have our proprietary scheduling algorithm where we are able to manage A2DP bursty traffic along with LE audio together, and everything happens so seamlessly as you can see in our audio.